The next big hydrogen investment opportunity is brewing right in front of our eyes. Yes, you heard that correct. Aviation, which is 15% of global carbon emissions, is about to see the next big shift towards electrification, and hydrogen fuel cells are expected to play a critical role in this industry, which will help drive demand for green hydrogen and fuel cell technologies globally. As an investor, it's extremely important to understand the ramifications of such an investment from some of the biggest entities in the aviation industry like Boeing, Airbus, and Rolls-Royce, and that is exactly what I want to explain in this video. But as usual guys, before we get into it, make sure to drop me a thumbs up and hit that subscribe button if you haven't already. So, to start things off, we need to understand where the electrification race for aircrafts is today, where it's headed over the next decade, and which technologies are really playing a critical role in this push, because obviously the amount of options we have available is very big. For those that might not know, electric aircraft are not really a new thing. There have been a lot of prototypes that have been developed over the past couple of decades that have demonstrated the ability to use electric motors and batteries to power small Cessnas and light-duty aircraft over very short distances. But as we all know, solving the bigger picture problem for commercial aviation is much more difficult because commercial aviation requires a completely different type of technology. See, commercial jet engines like you see on your typical Airbus or Boeing aircraft don't use the propeller technology that you tend to see on smaller aircraft like the Cessna. They use a technology called the turbofan instead of the turboprop. The turbofan technology is significantly more energy efficient at higher altitudes and higher duty cycles, which is typically why it's used on every single commercial airliner you see out there. The way that a propeller engine works is you convert the chemical energy from the fuel into mechanical energy through a compressor, and that moves a gearbox, which ends up moving a propeller. And it's this propeller that's typically outside of the aircraft that is pushing the air forward and as a result moving the aircraft towards the right direction. But this is obviously extremely inefficient because this is limited by the mechanical ability of the gearbox and the speed of sound. Because obviously the propeller can only rotate at the speed of sound efficiently. Anything supersonic becomes extremely inefficient and extremely dangerous to the mechanical stability of the entire engine. That is why traditional jet engines from Rolls-Royce and CFM, which is what you see on every commercial aircraft, use something called the turbofan technology. This technology essentially compresses oxygen and air into this very tight chamber, combusts it with kerosene, and then pushes all that energy out of the back of the engine, which ends up thrusting the entire aircraft forward. This is the entire reason that aircraft engines have these extremely small nozzles behind their chassis. That's obviously because the lower the area, the higher the pressure. And the higher the pressure, the more thrust that you can generate from that energy. And this right here is exactly what results in this massive electrification problem that we're facing for aircraft. You see, a traditional propeller engine can typically be powered by an electric motor and a battery. But the turbofan engine, which is obviously used on most airliners, cannot be used with an electric motor because obviously it relies on the combustion of a fuel. So the only way that we can decarbonize aviation on a large scale is by finding a fuel that we can combust efficiently that can provide zero emissions and also be produced in a renewable fashion. And that is where hydrogen comes in. Hydrogen is really the only fuel that we can make from solar panels and wind farms and then combust it with zero emissions. And that is exactly why Airbus is right now testing with a converted A380 aircraft, which is obviously their flagship model, and using a hydrogen turbine mounted to the back of it to test out combustion technology. Particularly in this case, they're using 4 liquefied hydrogen tanks, feeding it through a gas converter and then feeding it into the steam turbine that can end up rotating a shaft and then pushing air backwards, which will obviously thrust the aircraft forwards. And in this case, the reason why they're using liquefied hydrogen is because the energy density of liquid hydrogen is typically much better than compressed hydrogen. And obviously on an aircraft where space tends to be very critical, it's important for them to test out a technology that could be more economically viable, not just technologically viable. As a matter of fact, one of the world's biggest jet engine manufacturers, Rolls-Royce, has already tested a hydrogen combustion jet engine quite successfully on the ground. Airbus right now is only testing this technology in flight, and that is obviously going to be the next big step before we can actually decarbonize and bring these engines onto commercial aircraft. It's going to be a long road ahead, lots of R&D, lots of investment, but obviously we need to make sure we're investing in the right technology before making that investment and obviously reaching the 2035 goal of Airbus launching the first electric aircraft. And really the interesting thing here is that this is not really an electric aircraft because it does not use a battery or an electric motor. And this highlights the flexibility of hydrogen in such heavy duty applications and why in the long term this hydrogen economy is not really a fad. This is actually a fuel that is practical and can help us replace our addiction of kerosene, gasoline, diesel, and all these fuels that offer such great practicality at the cost of emissions. And well, for those of you wondering what exactly that practicality advantage is, well, as you all might know, hydrogen is extremely energy dense. It's actually 33.6 kilowatt hours of usable energy per kilogram versus diesel, which holds around 12 to 14 kilowatt hours. And when compared to your nearest lithium-ion battery, the energy density of cooled liquid hydrogen and even compressed hydrogen gas is over 20 to 30x that of your best form of battery cell. This is something you can't ignore, especially for mission-critical applications like aircraft, which obviously emit way too much every single time they're airborne. Because even if you account for the efficiency losses of making and storing hydrogen, you still get north of 10x the amount of energy you can store in a hydrogen system than a battery system. And in an aircraft where weight is so critical, where the more weight you add, the more range you lose, hydrogen technology is going to be the winner. And the high confidence of a manufacturer like Airbus about this hydrogen push really makes me more confident about my own investments in the hydrogen space when it comes to trucks, production, and distribution. Because as we all know, as more demand is created in an exponential way when it comes to aviation, the supply chain itself will start developing better and better, and the cost of the core technology and the fuel will start coming down aggressively.
You said this morning that you are becoming, quote, more confident in your ability to deliver a hydrogen aeroplane by 2035. Guillaume, the physics and the chemistry is incredibly complicated. What gives you that confidence?
The physics is complicated, but the physics works. Hydrogen technologies are not new. They are used in other sectors. We use them in space on our rockets. And we don't need the laws of physics to change to be able to use hydrogen on our planes. So every day we become more confident, but we think we need to have a plane, we need to have the right fuels, the hydrogen available in the right quantity at the right place at the right time, and we need the regulations to be ready. So we really need the work and the collaboration of many people around the globe to make it happen, and that's why we have the summit to create that momentum and make sure we have the right level of collaboration to make it happen on time.
What problems do you still need to solve? What needs fixing? And what kind of aircraft should we be thinking about? Is this kind of a turboprop-sized aircraft, a smaller aircraft, or are we thinking about a replacement for the A320 family?
The technology needs to be introduced in planes, in aviation, so we need to be able to deliver the fuel at the airport, to use the plane on board, to store it, to burn it or to use it in a fuel cell. There's a lot at stake at the moment. We are looking at those technologies, so it's not really about solving problems. It's about understanding the way we can use the different technologies and then selecting the right ones. When it comes to the planes themselves, hydrogen has different characteristics compared to kerosene. There is a higher weight density of hydrogen compared to kerosene, so it's good from the weight standpoint, but it takes more volume for the same quantity of energy. So the planes will have probably a different shape, a different architecture, and we will use less hydrogen in terms of weight, less hydrogen on board than with kerosene. So we believe we're going to start with short and mid-range aircraft before it goes to longer distances. So rather smaller airplanes at the beginning, which is also something reasonable to consider when you look at the investment that will be required. So smaller investment for smaller planes, easier go-to-market, and more convenient when it comes to the use of hydrogen.
Airbus' CEO is right. Hydrogen has been used in the rocket industry for many decades over the past 100 years. It's been used in a liquefied form, combusted, and used to propel these rockets, typically with zero emissions, even though the technology still has not developed into the commercial and industrial applications completely just yet. And that, for me, is exactly what is creating this investment opportunity in the first place, why I think the hydrogen economy is more real than hype. But obviously that is just my take on the situation, so let me know your thoughts down in the comment section below.